Hello and welcome to revision tips for SIPS Level 5, Advanced Diploma in Procurement and Supply. This is Module 10, Logistics Management, and this is about Learning Outcome 2, Understanding Capacity Planning and Control in Logistics Management. So we're going to look at the techniques that can be applied to the planning and controlling of logistics, and the techniques that can be applied to capacity management, and the use of MRP and systems technology in the control of logistics management, as well as reverse logistics. So planning is deciding on the following: what activities must happen, when do they need to be accomplished, what resources must be allocated. And control is the process adopted by organisation to cope with the change in plan. Could be in the form of interventions like introducing additional resources, like staff or technology, or outsourcing to a third-party provider. Controlling activities can happen across various functions like financial control, project control, and logistics control. All of these are subset of management control systems. Planning and controlling activities can be expressed as long-term, medium-term, or short-term. So in the very long term, managers make plans about their intentions and identify resource requirements and set long-term objectives. There is a little emphasis on control activities, but they can start to develop the type of control activities that should be in place. In the midterm, the overall aggregate demand would have been identified for the logistics operation to fulfill. Contingencies will be put in place for the change in plan, which will act as an additional resource, making it easier to manage planning and controlling in the short term. And in the short term, the objective will be to fulfill demand by striking the right balance between cost, time, quality, dependability, and flexibility. Short-term interventions will make to compensate for the change in plan. So, for example, if there is a sudden surge in unexpected demand and the transport department are unable to absorb the excess demand, control actions like using a third-party provider will be used. And monitoring will be undertaken at the detailed level to introduce appropriate interventions. The elements of logistics management, integration and information transportation, inventory, warehouses, material handling, packaging and security. And that's about achieving a balance between planning and control. And as we know, this planning and control are important activities for any organisation. The core objective of planning is to fulfil demand. But planning activities will place a demand on an operation, and control activities will intervene if operations are now not going to plan. In order to ensure the right balance, the section explores how planning manifests into capacity and then the scope of logistics and control. But the capacity is the quantity of demand that can be placed on an operation. But it also means the amount produced by machine or labour or land in any given time period. Problems arise when the planning team place excess demand on an operation, or they may not have predicted properly, resulting in over or underutilisation. Since under or overutilisation of resources are not part of the plan, control activities kick in and take action to bring the activity back on plan. So the resource utilisation is measured in terms of capacity. So what this is showing you here is various losses that a warehouse operation can face. So you can see effective capacity 45 minutes or 15 minutes per hour. You can get inefficiency of 5 minutes, slow equipment, unplanned breaks, or no work. So it just shows you where those losses can occur. But now we're going to look at responding to demand. And when we're responding to demand, the different areas of logistics will include procurement, production, distribution, after sales and disposal. Now, demand is a complex function influenced by a wide range of variables, like the weather, consumer buying patterns, that are influenced by economic conditions, promotions, competitor performance, and so on. These factors are constantly changing, making the entire demand planning a very challenging activity. So, demand management aims to balance the customer requirement with the capabilities of an organization. And what the screen is showing you is the position of demand management in a typical planning and control system. Now, the forecasts are based on anticipated events and not within the remit of the decision maker. But organisations should prepare executable plans, and when conditions change, the control function should change the plans and new plans should be executed. So the organisation has control over the plans and execution, but not the demand. But there are two types of demand. You've got independent demand and dependent demand. The independent demand is where demand for a product or service is not dependent on factors that can be controlled by the organisation. Dependent demand is dependent on the demand for another product. Now, we're going to look at the key planning and execution activities that an organisation will undertake to accomplish its objectives. So we're going to start with loading. Loading is how much to do. It's the process of determining and allocating the amount of work that can be assigned to ensure optimum capacity utilisation and load balancing among machines. Finite loading and infinite loading are two approaches that are taken by planning professionals while working sort of loading a work centre, if you like. But the sequencing is the order in which things are done. And the various factors that are taken into account will be things like physical characteristics of the products, the layout of your work centre, and the priority of your customer and the impact on cash flow. So sequencing options will include first come, first served, first in, first out, shortest process time, earliest due date, slack time remaining, or last in, first out. But scheduling is the detailed timetable of what work needs to be done and when. A detailed plan of what needs to be accomplished in the shortest term can be a simple to-do list or can be a minute-by-minute plan for the live event. Operation scheduling is a core activity of a business and generally organisations employ a dedicated scheduler. But logistics scheduling encompasses an area of supply and production and the delivery. Monitoring and control is a regular activity performed by the operation manager. Once they've finished the loading, sequencing and scheduling plans, the monitoring aims to capture the progress of an order. One of the challenges relating to monitoring and control is identifying what to monitor and how to control it. So, for example, assuming the time spent by truck drivers in satisfying customer orders is being monitored, or record indicate that specific truck driver has been consistently exceeding the allocated time and the number of deliveries made in a day is less than the target. And obviously, this is an area of concern, but the driver may have built a strong relationship with the customer, resulting in positive brand image that has led to the increased revenue from the client. It's necessary to carefully choose what to monitor to identify the underlying causes behind the observed phenomena and take the appropriate action. A dictionary definition of capacity reveals several meanings, including the physical ability of an object to store something, an individual's mental or physical ability, legal capacity to stand a trial, economic output of a region of operations. But in the context of this chapter, capacity is interpreted as the quantitative expression of resources, people, equipment, and materials that work together to create value within a business. In other words, it's the amount of output that a resource can produce in a given time, or it can be the amount of input that a resource can process in a given time. The goal of a logistics system is to provide a stipulated level of support to an operational system. And the logistics system capacity can be measured in aggregated input and output terms for ease of analysis. So, for example, the capacity of a work centre that repairs photocopiers can be the number of repairs completed over a unit time period, like the days of a week. But in order to understand the concept of capacity, it's important to know about the throughput time, production rate, utilization rate, and the waiting time. So let's have a look at some of these terminologies with some examples. Throughput time is the average amount of time spent by each output in the system. So the business of repairing photocopiers, we could look at the average time in systems per item is processed. So you've got one employee, one photocopier per day, and the time to repair it, let's say it's 7 days. So the average output per day is one copier per day and 7 days per photocopier. That's your throughput time. Production rate is the average number of units leaving the system per unit time. So the total number of output in the time period. So that would be one photocopier per day. The utilization rate is the available average fraction of production time during which productivity facilitates activities that are processing units through the system. It's measured as a percentage of capacity used or capacity available. So a warehouse has a capacity to process 100 orders a day, but on a given week it processes 80 orders. The utilization here is 80%. And then waiting rate, the idle time of material that is waiting to be processed, measured in percentage of throughput time. So it's the waiting time divided by the throughput time multiplied by 100. So on an average, it takes 3 hours for a truck to enter a facility, offload the materials and leave. Of the 3 hours it spends, 1 hour waiting for its turn. Hence, the throughput time is 3 hours and the waiting rate is a third, which is only 33%. But capacity constraints are caused by a range of internal and external factors. These are the factors that are preventing a business from producing the quantity that it wants to produce. And the internal factors range from minor bottlenecks like broken equipment to significant ones such as lack of capital or skills or space. But external factors like the government regulations can act as a constraint. So, for example, the government might impose quotas that limit the amount of fish that can be caught over a specific time period. Likewise, constraints can be applied on an organisation's growth or market share in order to prevent the formation of monopolies. So the constraints can be physical, policy, cultural, or market-led. But in terms of planning and controlling your capacity, we'll start by looking at warehouse planning. So a traditional view of a warehouse is to place or hold or store inventory for coordinating supply and demand, but that's been transformed. It's now a centre that aims to provide better customer service through techniques like just in time and reduce transport costs by mixing inventory from various sources and delivering it to different customers. The key functions of a warehouse include cross docks, storage, break bulk, reverse logistics, and customer order fulfillment. But some warehouses have started providing additional services like repairs and warranty. But a warehouse could just be a large scale storage facility, which can be standalone, for example, not connected to the manufacturer, assembler, or retailer, or integrated, like IKEA or Costco, where the warehouse is integrated on the same site. So, warehousing capacity planning occurs at two levels, strategic and operational. But warehouse system designs is an example of long range strategic decisions. Strategic level decisions will look at things like the location, the capacity, the ownership, whether they should own or lease the warehouse, what technology they'll use and material handling equipment, the product flow design, the journey it will take when it goes in and out of the warehouse. Think of IKEA again, that's got a very specific product flow design. And then the services offered, what type of service will we get? Will we get cross-docking, consolidation, reverse logistics? So at operation and tactical level, you'll look at decisions like the warehouse layout. Should it be I-shaped, U-shaped, or L-shaped? Sometimes it looks like a horseshoe, and it depends, I suppose, on whether you've got the goods in and goods out on the same side of the building. Will you create different zones so that goods can be stored in common characteristics, like frozen foods and chilled foods and ambient foods? Or it could be on weight, volume, frequency of use, like the ABC analysis. What type of equipment will you use? I mean, you can see examples on here of kind of wide aisles or narrow aisles and the different type of equipment you might need if you decide to go up high and use the full cubic capacity of your warehouse. The number of docks for receiving and shipping, the dimensions of your systems, the head count, and the amount of your equipment that you can have in the facility, as well as allocating downtime so that these machines can be charged overnight. But you'll also look at productivity measures like utilization, labor costs per unit, the amount of space needed, the frequency of errors in picking and packing, and so on. So there's lots of methodologies for designing warehouses, but it's important that you emphasize that warehouse design is one of the key activities in developing your logistics capacity plans. A forecast consists of a time period, a product, and a geographical region. But key points about forecasting is that it's usually a monthly activity. It starts with preparing or gathering historical sales data and confirmed orders. The data is analysed and predictions are made by analysing patterns in the data. The generated forecast is then shared in the sales and operation planning meeting. Once a consensus is reached, a forecast for dependent demand is generated. The data is then realised and shared with relevant partners and is used to generate a master production schedule, transport planning, warehouse storage requirements, and a demand normally consists of a trend, which will be a gradual shift or trend over a period of time. So, for example, demand for desktops has slowed down and laptops have increased. It would include seasonal elements, like the regular variations in demand caused at certain time periods, like ice cream sales go up in the summer, umbrella sales go up in the winter. Cyclical elements, which can be quite challenging to predict. So, for example, the economy is always cyclical in nature. Are we in boom or are we in bust? There's random variation, which is also difficult to predict as it's based on random events. So, for example, in 2016, there was the Japanese earthquake, which severely affected Sony's supply chain. And autocorrelation is the correlation between the expected and past value of data, a useful component when predicting demand. But the demanding process you can see on the slide is preparing data, performing some sort of analysis and gaining a consensus, planning for that dependent demand, and then you can release your forecast. But the demand forecasting techniques are broadly classified as either quantitative or qualitative. The quantitative stuff is derived from data and past transactional history. It's objective, it's a commonly used technique. You can use things like time series, causal methods, or exponential smoothing as techniques to understand quantitative data. But the qualitative stuff is subjective because it's based on opinions. It's usually the perception of decision makers. So they do draw on the past experience, but also include a bit of market research and insight about what might happen in the future. And the techniques here will be things like Delphi methods and market research. But there are several factors that can create issues when you're forecasting, like lack of understanding about your micro and macro environment, poor data quality, or lack of information sharing. Now, capacity can be expressed in terms of output and input. So the output capacity measures the amount of aggregate output the business can produce, whereas the input measures the amount of input that can be processed. So logistic cuts across the organisational boundaries and involves a wide range of stakeholders, such as customers, suppliers, government, public infrastructure. And logistics service providers can be tangible or intangible. So, for example, a tangible logistic provider would be a transporter or a warehouse provider, whereas an intangible one would be a forwarder or a financer or an insurance provider. But these logistics service providers have different methods of expressing capacity. So a transporter will express the capacity of a truck in terms of the weight, kilograms, tons, or the volume in cubic meters. Truck providers will also state the number of vehicles in the fleet. Warehouse providers express capacity as the amount of space available for storage. It could be a floor area in square meters or some sort of cubic volume. Freight forward express capacity in terms of the number of people and the knowledge about that industry they have, and the number of shipping routes they serve. Finance and insurance providers express capacity in terms of the upper limit for insurance that they can provide, or the type of insurance they offer. The key points about producers is they comprise the majority of logistic functions. They are diverse in nature and can be broadly grouped based on the type of product they produce and the flow of materials during the transformation. The products they produce can be standardized repetitive products like a detergent, or they can involve high volume assembly like a car manufacturer or bespoke job in operation. So capacity measures will be different for different types of outputs. For high volume products, capacity can be expressed in the terms of output capacity. Units of capacity measures change from output-based measures to time-based measures. But the key points about job in process is that every job is unique in nature, and a set of machines are used to produce diverse outputs. And capacity is measured in terms of machine availability and staff hours. A job shop specialised in electroplating will express capacity based on machine hours that are available. Now, the operations planning aims to match capacity with demand so that resources are utilised to the optimum level. There are three basic strategies used by organisations when considering matching supply and demand: level capacity, chase capacity, and mixed plans demand management. The level capacity plans keeps the amount of output constant through the planning period. This means that the output will be the same irrespective of a change of demand. So demand can go up and down, but capacity will always remain the same. If you're adopting this approach, you'll result in the optimum utilisation of your resources. You'll be able to produce the output at the least unit cost. So you make stock and you hold it until demand exceeds capacity. The chase demand, on the other hand, requires the business to alter its capacity to match demand. Ability to alter output can be a differentiator for a business and result in enhanced competitive advantage. So chasing capacity requires a flexible infrastructure and an agile mindset. Suppliers must also be in a position to alter their output so their entire supply chain work in sync. In order to chase demand, the business needs to be able to hire and fire employees, alter the production capacity to decrease hours or add additional shifts, and subcontract production and storage to a third party, or use additional inventory to absorb fluctuations. There can be inherent challenges associated with chase demand. It may not be cost effective because customers are not willing to pay extra for the additional costs. And it's challenging to actually calculate the unit cost because they could be hidden. All the associated costs with hiring and firing are very hard to identify. And it calls for a high level of coordination. Decisions are data driven, and top management support is essential for this approach. But demand management, moving into that kind of mixed plan approach, is adopted by organisations to control demand so that demand fluctuations can be smoothed. In chase strategy, businesses tend to vary the output to match demand, but in demand management, the business tends to alter demand so they can absorb variations. In order to generate demand during off-peak, a variety of strategies can be adopted, like variable pricing and peak and off-peak pricing. You see this quite a lot with trains, They don't just make trains longer on busier days. They're the same length. Sometimes they're full, sometimes they're empty, but they'll obviously charge us variable prices for peak and off-peak times. Or it could be marketing activities, adopting a new channel of marketing to increase the initiatives to raise better awareness, or developing new products that can use existing facilities that are designed and offering customers smooth demand. So this is an approach that combines level and chase demand strategies. So the inventory is accumulated and some capacity is adjusted to cater for the changes in demand. Now, MRP stands for Materials Requirement Planning, and there are a few key points to note. It's driven by software application. It's a core activity, especially for organisations involved in assembling and batch manufacturing. It creates time-phased material plans for dependent demand with the core objective of providing the right parts at the right time. The material plans are created by getting input from the bill of materials and inventory status. Material plans help to create capacity and procurement plans, and MRP operates in response to the anticipated demand for a finished good, which could be a combination of firms' orders and forecasts. The key output of an MRP system is the development of purchase orders for one-off items that are not in stock. The logic of this application is different from a reorder point, which is based on the logic that decisions to buy a particular item are made when the stock reaches a specific level or is scheduled for a specific time period. So the decision to order the item is not based on specific inventory, like forecast or dependent demand. An MRP system aims to accomplish things such as developing production, distribution, purchasing and delivery plans, ensuring product availability, which includes finished goods and raw materials, keeping the costs down by striking a balance between the level of service and the cost. But the system will require various types of information to determine the material requirements, such as the master production schedule, the bill of materials, the inventory status of all the items that go into that finished item, the lead times and the routing information of the products. But MRP2 is an extension of MRP, and it's gained popularity in the 1980s. So it got translated into manufacturer's resource planning, and it distinguished its capacity from other systems, because whereas MRP looks at the materials, MRP2 looks at the resources that you need. And then ERP stands for Enterprise Resource Planning, and a term was coined by the Gartner Group in the 1990s. It has all functionalities of MRP2, but it also includes finance, supply chain, HR, and project management. These systems are also known as enterprise systems because they aim to provide a unified picture of an organization by storing all the data in a centralized database. They provide information backbone of the company. So the ERP gained popularity mainly due to its capability to integrate various business functions in manufacturing. You've got the logistics, the human resources, the finances, and the customers to user needs. It provides an inbuilt best practice that allowed businesses to re-engineer their processes. Previous software applications calculated years by only using the last two digits, which worked until 1999. But in 1990, ERP was marketed as being a year 2000 compatible. It addressed the computer flaws that were caused by problems if they were left unchanged. So for the year 2000, the result would turn negative due to the 00. But in order to fix this flaw, businesses across the globe looked for a solution to fix the bug, as they had larger suites of applications with very little integration between them. So there are a number of characteristics of an ERP system which contributed to the massive explosion of its adoption. You have a centralized database. It's modular in nature in the sense that you can have, SAP integrating with other systems like Oracle. You've got inbuilt best practices, multilingual, multi-currency, and three-tier architecture. So it's got the database layer, the application layer, and the presentation layer. The inter-organization integration and the fact that it's customizable. Real-time processing and reporting using something called a data warehouse. But the master production scheduling is the development of a detailed plan with the core objective of fulfilling customer demand. Firstly, the sales and operation team will work together to develop an aggregated production plan. This will then be translated into a tentative master production schedule, which will be tested against the ability to meet the deadline with the given resources. This will then be refined, adjusted by gathering inputs from several departments. Then it can be finalised. Once approved, the final MPS will be used as input calculating the material requirement plan. But the master production schedule is the anticipated production plan for satisfying that customer demand. This enables the business to offer some level of guarantee to its customers. It ensures production is aware of capacity utilisation, and it enables top managers to track against the targets. So it gets information from the following sources: forecast demand, the customer's orders, current and planned capacity, and stock level that's available to meet your customer demand. But intrinsic in this is the bill of materials, or the BOM. When the MRP, the master production schedule goes into the MRP system, it will actually explode something called a BOM, which is a bill of materials. So the explosion of this process is calculating the materials required for each individual component part that's going to satisfy the order, but it deducts the current inventory of the components and any anticipated deliveries from suppliers. So the gross to net explosion is an important functionality within the MRP system, and it only happens for the component part requirements, for which existing inventories and components are considered. The typical BOM structure is hierarchical in nature, but it contains information like the quantity, name, product code description, level, cost, and unit of measure. It can be either single level or multi-level. A single level BOM is normally used for simple products for one-stage production, whereas multi-level BOMs are suitable for complex assemblies and instances where semi-finished goods are produced in-house. But as I said, it does look at the inventory data. Inventory data forms a significant input into the MRP program. Due to the wide range of information it holds, things like the item code, the description, the MOQs, that's minimum order quantities, the lead times, unit costs, the minimum stock levels, the current stock levels, inventory class, and usage data. So the MRP applications are useful in environments that have well-defined product structures, where the end product is produced by assembling many subcomponents. And this is usually known as the multi-level bill of materials. But it will use demand for top-level components as an input for level 1 subcomponents, which in turn generates the requirements for the level 2. And purchase orders are generated based on the materials required by the application. But in reality, a subcomponent procured to satisfy a certain order may be used for another purpose. This can be avoided by linking incoming supply and demand. This is known as pegging. An MRP system allows two types of pegging: hard pegging and soft pegging. Hard pegging links a specific purchase order to a specific sales order. Any change in demand or supply will have a corresponding effect on the other. So hard pegging does not allow stock reversed for a specific order to be used to satisfy another. But soft pegging will allow the supply to be linked to multiple demands. Any change in the sales order will be notified to the procurement department, but no action will be taken to alter the purchase quantity. In order to determine the materials requirements, the MRP system requires a lot of information. It needs to know the master production schedule for the finished product. It needs to know the bill of material information, which includes assemblies, sub-assemblies, and other items that go into a product, the inventory status of all the items, lead times, and the routing information. And the table on the screen shows you the MRP gross requirements. So it starts from that gross requirement, which is the anticipated demand for a specific component. The gross requirements can be derived from the sales and operation plans and the bill of materials. They are dependent on demand items. So the requirements are calculated for a period of time, which can be a week, a month, or a quarter. These periods are also called time buckets, and requirements are expressed as unique time periods rather than aggregated or averaged. Generally, the requirement varies with time. So presenting the requirement according to the time period allows planners to accommodate the change required due to seasonality trends and special orders. But there are some limitations of the MRP system. It reduces inventory costs. Sorry, these are the benefits. The benefits of the MRP system is reducing inventory costs, better customer service, improved capacity and time reduction, as well as increased sales. But in reality, the requirements change continually due to factors like the customer decides to change requirements, or a supplier doesn't deliver on time. What about if the machine breaks down, or there's an unexpected order from a customer, or changes in the product design are introduced? So the challenge of customer returns and returns management need to be considered. And in a supply chain, the product generally moves from one end to the other, i.e. from producer to the distributor, to wholesaler to retailer, and then to the customer. But in recent years, organisations have faced increasing amounts of goods flowing backwardly in the supply chain, and this is known as reverse logistics. Generally, a product's life ends with a consumer, but reverse logistics and recycling aim to take care of the product after the end of life. And there are various flows that happen in the supply chain. So from a customer to a retailer, you might get product returns, you might get warranty returns or end of life returns. Retailer to wholesaler, distributor, or distributor to manufacturer might be product recalls, damaged or wrong items, or unsold items. And from the manufacturer to producer, it could be a raw material return, a quality issue, or waste, unused stock. It can cost double the amount for a product to be returned in the supply chain as it can to deliver it. So the challenge of customer returns and demand management require product returns that happen at different stages within the life cycle to be grouped together into end-of-life returns and product defect returns. End-of-life returns happen after the customer has fully used the product. It's not economically viable to convert the remaining product into something usable, so it's considered to be waste. Extended producer responsibility is legislation that gives producers a significant responsibility for the disposal or treatment of end-of-life consumer products. But the regulations have provided the following requirements for businesses: minimum waste from products and the promotion of reuse, ensuring waste products are treated and meet recovery and recycling targets for the waste materials, designing products by reducing material use and enhancing reusability and recyclability. But recycling can happen at the following three levels in an industrial environment: within the organisation, within the supply chain, or large-scale recycling. Product recalls are requests from manufacturers to consumers to return a product after the discovery of a safety issue or a product defect that might endanger the consumer or result in legal liability for the producer. They are common in the automotive, food and electrical appliances industries. They result in additional costs and need to be streamlined for processes for managing the recalls. Now, processing defect product returns presents various challenges. It's difficult to forecast the number of product returns, and there are transportation challenges due to returns usually being single items. But when a seller trades in goods or services against a specific request from a customer, a legally binding contract is formed between two parties. And being a legal contract, it can be enforced by law. So, customer return policies explain the rights of consumers in terms of warranties, returns, and exchanges. And these policies can be based on the product or type of service that they're buying, essentially, or it could be the geographical location and the mode of purchase, whether it was online or offline. There are some country-specific regulations, but almost all countries have some returns policies that favour customers. So in the UK, we have a 14-day returns policy, whereas Canada have a 30-day policy. There's a minimum legal obligation that's set by respective governments, but organisations can develop their own returns policy as long as it's more than the minimum requirement. But return policies can be classified as restrictive or lenient based on 5 dimensions: time, value, effort, exchange, and scope. In terms of the redistribution of returns into the supply chain, this is about making decisions about returned items, and that can be complex and challenging for a business as it's dependent on a range of factors like the product condition, demand, restocking cost, and system capabilities. But generally, products are classified as durable goods or consumable goods. And when a business receives a return, the process is faced with lots of challenges. So, say the product isn't in its original condition. If it is in its original condition, it can be restocked, but if it isn't, it can't. If the product is good as new, but now the packaging's been removed, it can be repackaged and sold at a discounted price. If the product is faulty and within the warranty period, it can be returned, remanufactured, refurbished, or if it's not economical to repair, the value is extracted from the product disassembly. I guess the last resort here is to send the product to landfill. And that is the end of Learning Outcome 2. Thank you for watching.